welcome back. Today we're going to do patterns in linear equation. So we're going to take a look at some word problems and some tables and see if we can determine if the equation is linear, and if it is linear, write the equation in slope-intercept form. So a pattern. If there is a pattern in the linear equation, it is determined by either adding or subtracting the same number to both the y, and then we're also adding or subtracting the same number to the x's. Now, it doesn't have to be adding or subtracting the exact same number for both the x's and the y's, but the y column has to be adding or subtracting the same number. The x column has to add or subtract the same number. It can never be multiply or divide. It always must be adding or subtracting. So to write my equation, remember the equation is slope-intercept form, y equals mx plus b. So we need to know m, the slope, and we need to know b, the y-intercept. So the most useful form of slope that we're going to use in this section is going to be the version of the change in y over the change in x. Okay. So the change in y over the change in x. Rise over run isn't going to do us a whole lot of good since we don't have a graph. We could use the formula for slope, but the change in y over the change in x is going to be a lot more useful. And the y-intercept, we've learned from the last section that the y-intercept is found by letting the x value equals 0. All right, so let's give this a shot, given a table. So the first thing you want to do is take a look at the table, and we want to determine from this table, is there a pattern? So look down your x column. So from -2 to -1, do I add or subtract the same value? So here I added 1. From -1 to 0, I added 1. From 0 to 1, that's an increase of 1. From 1 to 2 is an increase of 1. So down the x column, it looks like we are increasing by 1. My y column, 9, 6, 3, 0, 3. So from 9 to 6, we're subtracting 3. 6 to 3, we subtracted 3. 3 to 0, we subtracted 3. And from 0 to -3, we subtracted 3. So it clearly states that we have a pattern. In both the x column and also the y column, we are adding or subtracting. So is this one linear? Yes, absolutely. This is a linear pattern. So now we want to write my equation of my linear pattern. So don't forget my linear form, y equals mx plus b. So we need to find the slope. So we need to find the change in the y over the change in the x. Well, this is pretty convenient because we know the change in the y. The change in the y is given to us by a column here. The change in the y is the -3. The change in the x column we can see is the +1. So my slope is -3 divided by +1. So my slope is -3. So I can substitute in for my slope -3 in place of m. And in place of b, my y-intercept. Well, that's found by letting my x value equal 0. Well, when I look at my points, I have a point where x is equal to 0. That's the point 0, 3. So my b value is 3. So I can finish up my equation. Y equals -3x plus 3. Now we can go back and easily check our equation. We can substitute in any of our x values in place of x and evaluate that expression and get our y value. So for example, if I choose the first point up here, -2, I could substitute in -3 times -2 and get 6 plus 3, and that gives me the 9. So I know that that point is definitely a point on that line, so I know I found the correct equation. Okay. Number 2, a word problem. When we have a word problem, the easiest thing probably to do for that word problem is to create a table. Okay. So let's take a look at this word problem. The cable and the internet bill cost Waldo $1.30 each month. X represents the number of months, Y represents the total cost. So let's create a table for this information. So X is representing the total months. Y represents the total cost. So let's use our domain values. Okay. We're going to let X be 0. So if X is the total months, we can't start with negative numbers because it can't have negative total months. Doesn't make sense. So at 0 months, how much is it going to cost? Well, at no months, it's not going to cost me any money. At 1 month, it's going to cost me $130. So it costs 1 month $130. 2 months, I paid now another $130. So $260. 3 months, I paid another $130. So now I'm at $390 and so on. So is this linear? Again, we're going to look for our pattern. So on my X side, I've increased by 1, increased by 1, increased by 1. So definitely a pattern there. On my Y side, I've increased by 130, added 130, and added 130. So again, my pattern is adding each one. So is this one linear? Absolutely. So now time for my equation. So Y equals, so my slope is the change in Y over the change in X. So my changes in Y was adding 130. The change in my X column was positive 1. So 130 divided by 1 is 130. X plus my B value, my beginning value in this case. When X is 0, Y is 0. So plus 0, but we know we don't write a plus 0, so my equation is Y equals 130X. Okay. Now would be a good time to try these at the bottom, okay, and see if you can come up with if they are linear or not, and their equation. All right, welcome back, and let's see what you found. So let's take a look at our problem. So for the first one, as I go down my column, I can see on this side we're adding 1 each time. On the Y column, I can see I'm adding 2 each time. So yes, this one is linear. So for my slope, I have my change in the Y over the change in the X. My change in the Y was add 2. The change in the X was add 1. So my slope here was 2. My y-intercept was when X was 0. So if X is 0, Y is 3. That's everything I need now to write my equation. So Y equals my slope of 2X plus my y-intercept of 3. Your next one, here, we're adding 1 every time. Here, from 2 to 6, added 4, 6 to 18, I've added 12. That is not a consistent pattern, so no, it is not linear. And when it's not linear, you are not writing your equation. If you do look for a pattern, you could see here that my pattern is multiplying by 3 each time. So multiplying by the same number is not what we're looking for a pattern if it's linear. Remember, my pattern for linear is I have to be adding or subtracting the same value each time, not multiplying. So multiplying by 3, that is a pattern, but that means it is not linear, because multiplying is not what we're looking for. Okay. All right, our word problem. Groceries cost $60 per week. X represents the number of weeks. Y represents my total cost. So it's a word problem, so maybe a table would be helpful. So we'll start off with X is 0, so that's the number of weeks. Y is the cost. So at week 0, of course, I haven't spent any money. At week 1, I should have spent, let's see, $60 per week. Week 2, another 60. Week 3, another 60. So up to 180. So is this one linear? Yes, it is. Because here my increase was adding 1. There my increase was adding 60. My slope my change in my y's over the change in the x. So my change in my y's was a plus 60 over the change in the x plus 1. And of course, 60 divided by 1 is 60. So when I write my equation, y is 60x plus my y-intercept here of 0, but we do not write a plus 0. And the last one, David has 100 M&Ms. He's half of the M&Ms that are in the jar each day. Sounds good to me, but I wouldn't be eating M&Ms. It'd probably be Reese's Pieces. Okay, so let's make our table. So on the first day, X is the number of M&Ms that he's eaten. Y is how many are left in the jar. So there is 100 M&Ms left in the jar at the beginning. On the first day, he has eaten half of them, so there's only 50 left in the jar. On day 2, he's eaten half of the 50, and so on. So I can see there's a solid increase with adding 1. But down the Y column, I've either divided by 2 each day or multiplied by 1/2. In either case, multiplying or dividing is not what we're looking for it to be linear. I'm looking for adding or subtracting. So multiplying and dividing is not linear, so do not need to write that equation. All right, that is patterns in equations.